Good day to all of you. This is the session we are treating with the intermediate chemistry. This is very much helpful for your preparation towards international entrance exams or else competitive exam you are seriously preparing for. India level, JEE Advanced, JEE Mains that will be fetching for your IIT, NIT entrance examination. These are purely technical domain across India, and NEET chemistry, which is helpful for medical entrance examination all across the India. Telangana and Andhra Pradesh are conducting MCET examination for engineering stream. BTech entrance exam will be conducted. There also the type of session will be very much helpful. In addition, if you are aspiring for any government examination, there general studies is the common paper which is compulsory for each and every aspirant. In that, general science content will be there. The topic what we are discussing is very much fetching towards your preparation. Let's enter into our today's session. Explain the optical isomerism of following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, RS nomenclature to be assigned. Optical isomerism is given for the compound where chirality is present. The carbon which is accompanied by 4 different functional groups is said to be a chiral carbon. In this compound, you can find this chiral carbonatum and this chiral carbonatum. Okay, so if two chiral centers are present in the given compound, the set of RS notations to be given 2 carbons individually. Let's see how can we assign this. In order to give that one, let me consider this carbon where we have one side methyl, another side ring, and one more is if a fourth atom is not mentioned, that by default we can consider it as a hydrogen, because always balance of carbon will be satisfied by 4 bonds. If 3 bonds is known to you, another 4th bond we have to assume that will be hydrogen, and moreover 2 bonds in the plane, 1 bond towards the your wedge bond, so that obviously 4th bond is away from the your hydrogen, right? This is the way we can mention. After mentioning, let me take this side carbon with this longest chain, so that this is taken as a carbon number 1, and this side carbon with the shortest side, so that this carbon is taken as carbon number 2, and methyl carbon is taken as the 3, and hydrogen obviously of 4th priority. So if we are moving from first to second, third in this manner, this is moving in an anti-clockwise rotation. Anti-clockwise is also known as counter-clockwise. Counter-clockwise rotation designated as a S configuration. S for sinister, right? So RS notation is also called as absolute configuration. Anti-clockwise always designated as S configuration. If already 4th priority is backend, whatever rotation we have, that rotation directly assigned with the configuration. It is of anti-clockwise, so that S configuration. Move on to this 4th carbon. On the 4th carbon, this side is taken as the longest chain, so that first priority, and this is a shorter chain, so that second priority carbon. And here we have ethyl. Ethyl is taken as a 3rd priority, and hydrogen obviously of backend, so that 4th priority. Moving from 1, 2, 3 option like this, it is again said to be a counterclockwise or anti-clockwise movement. Anti-clockwise is designated as a S configuration again. So that in the given compound, 2 carbons are accompanied by S and S configuration. So this is the way absolute configuration RS notations are provided for the compound. In order to give RS notation for more than 1 carbon, we have to consider one of the carbon and assign bonds where they are located. Later on move for the priority. So first give the numbering to the priority. After giving number 1, 2, 3 in that manner, we have to look forward. If it is clockwise, R will be given. Anti-clockwise, S will be given. For these 2 carbon atoms, we are moving in an anti-clockwise or counter-clockwise rotation, so that SS configuration can be accomplished. This is the way compound number 1 is given with S and S configuration as per the IUPAC protocol. Move on to Second question. Second question is taken from Cambridge Assessment International Education. Complete the dot and cross diagram to show electron arrangement in one molecule of hydrogen. It is the fundamental question. Hydrogen molecule when formed, dot and cross structure to be mentioned. Here, two lobes indicates two hydrogen atoms whenever they are sharing electrons by the covalent bond formation. Always covalent bond is formed between the atoms of similar or identical electronegativity. That's the reason why they will share the electrons, and the electrons whatever shared are the common for each and every atom. One of the hydrogen is contributing electron mentioned with the dot. Another hydrogen contributing electron is mentioned with the cross. So two electrons are shared so that bonding between two hydrogens are common with these two electrons. This is the way dot and cross structure is given for hydrogen molecule, right? Question number 2 is answered like a dot and cross structure like this, right? Move on to question number 3. Question number 3 is collected from JEE Advanced 2019 question paper, paper 1 question. It is correct option to distinguish nitrate salt of manganese and copper taken separately. So manganese and copper salts were taken, and they are supposed to be identified what ion it will be. So you are going to analyze cations of the given salts. Okay, distinction between the cations, manganese and copper cations to be identified. This is the question given from analytical chemistry in specific salt analysis, we can say. Salt analysis is the practical oriented type of concept it will be. So this is conducted in the laboratory enhance. So enhanced experience is given to the students or learner by performing this laboratory salt analysis method. Okay, according to this identification, what we are doing, let's see. Manganese plus to show characteristic green color in the flame test. We have to identify whether it is correct or wrong. Only copper plus to show the formation of precipitate by passing to H2S under acidic medium. Only manganese plus to show the formation of precipitate by passing H2S. H2S is called dihydrogen sulfide. Rotanic smell containing gas is a faintly basic medium. Copper plus 2 and copper has the higher reduction potential in comparison to the manganese plus 2 and manganese measured under similar conditions. These many comparisons are provided. We have to identify which options are correct. Among all, B option and D option are correct answers. Else A and D are, A and C are wrong options only. Let's see how can we answer this one. Go to the flame test. So solution is provided. Before going to see the solution part, we have to go for flame test. Whenever this is copper was placed on the flame. Whenever copper placed on the flame, how it is burning? It is burning with a green color flame. Whenever manganese placed on the Bunsen flame, it is showing a golden yellow color flame, right? So this is the way you can distinguish. So copper, it gives a green color, and manganese gives a golden yellow color flame upon flame test. Copper shows the characteristic green color on the flame test. So, but they are saying manganese giving green color flame test. This is wrong one. So that A is not correct answer. Move on to copper showing the formation of precipitate by passing with H2S under acidic medium. Let's see. Whenever copper ions were copper plus 2 was taken and treated with H2S, copper sulfide precipitate will be formed. This is under acidic medium. Absolutely correct. Okay. So copper only forming the precipitate upon passing with the H2S, and the precipitate will be copper sulfide precipitate. That is also correct one. B is correct answer. Only manganese shows the formation of precipitate by passing H2S under basic medium. If you are going with the basic medium, manganese upon treating with HTS, formation of manganese plus 2 and sulfur element will be formed. But excuse me, only manganese is forming salt, they are saying, but not copper. But both are able to form. Let's explain. Both the copper and manganese able to give the precipitate upon treating with HTS under basic medium. Okay, so they are saying only manganese able to, but copper also having provision to give the reaction under basic medium as well, right? Copper plus 2 and copper has a higher reduction potential. Copper plus 2 and copper has higher reduction potential than manganese plus 2, right? So let's see. In order to explain that one, we have to go for electrochemical series. Copper plus 2 reduction potential is higher in comparison with manganese plus 2. This is the correct one only. Let's see the quantified values. Who can we see? If you observe, manganese is having the value of negative 1.18 and copper having the value of positive 0.38. What does it mean? Why negative is indicated for manganese? Why positive is indicated for this copper? Because manganese having susceptibility to release the electrons and copper having the provision to accept the electrons, so that manganese performs an oxidation reaction, copper involved in the reduction reaction. That's the reason why manganese is showing the negative 1.18 value, copper is showing plus 0.34. So in the statistics value, copper is having higher in comparison to the manganese. Manganese value is negative, no? Always we can treat negative values are lower in comparison to the positive values. That's the reason why copper standard electrode reduction potential value is higher in comparison with, to the manganese. This is the correct one. So according to the entire data, what we saw, manganese is giving characteristic green color. Wrong one. Manganese what color? Gold and yellow color you can see. Green color given by copper. Only copper gives the precipitate with HTS. Absolutely correct. Only manganese shows the precipitate upon HTS treatment under basic medium. Wrong one. Manganese in addition to the copper both are able to give. Copper plus 2 and copper has the higher reduction in comparison to manganese plus 2 manganese. This is the correct one. Only B and D are the correct answer. For question number 3, B, D are the correct answers. Move on to question number 4. Question number 4 is collected from JEE Advanced 2019 question paper, paper 1. अभिक्रिया और अभिक्रियाएं जो 1, 3, 5 ट्राई मिथाइल बेंजीन 1, 3, 5 ट्राई मिथाइल बेंजीन की रचना करती हैं. Okay, so abhikriya, so these many reactions are provided. Among all, how many are able to give a product? What product? 1, 3, 5 trimethyl benzene. This is called mesitylene. The mesitylene is synthesized from how many type of reactants? Okay, this is called acetone. Acetone treated with what? Concentrated sulfuric acid. What is the nature of concentrated sulfuric acid? It is the dehydrating agent, able to remove water so that it will be cyclized to give this compound what they are saying. This is perfectly correct. And when we are going with propine, this is called what? Propine. Why it is propine? Taken with the 1, 2, 3 carbon atoms with the triple bond, so that we can say it is a propine. Propine having provision to cyclize Tatpuloh nickel 873 Kelvin temperature, right? So here metal rod was taken and propine is the material. This is a kind of polymerization, trimerization, we can say, cyclization reaction carried. If you are taking acetylene, purely benzene will come. But when we are taking propine, so that we will get 1, 3, 5 trimethyl benzene. This is correct. They are taking this compound, which is a kind of triacetyl benzene. This is called triacetyl benzene. Triacetyl benzene treated with bromine NaOH, water, soda lime. So that what will be the product? It will not give. When we are taking this benzene trialdehyde, zinc amalgam HCl, this is simply called what? Clemmensen reduction. Clemmensen reduction is very specific for reduction of ketones and aldehydes into alkanes, so that wherever aldehyde is there, that turned into methyl. That is the product what we are expecting. So that A will give, B will give, D also will give. A, B, D are the expected answers. How can we get? Let's see. Okay, here is the compound called acetone. Acetone, when initially we have to go for ketoenol tautomerism. Acetone will be always existing in ketoenolic tautomerism. Upon converting into enolic form, further you can go for treating with sulfuric acid that will dehydrolyze. removes water, so that cyclization, and you will get macetylene. This is simply called macetylene, and otherwise you can say 1, 3, 5 trimethyl benzene, right? And this is the compound called propyne. Propyne heated iron tube was taken 873 Kelvin, extremely large temperature to be operated, so that it will become red hot iron tube, and this will be polymerized and cyclized to give a acetylene. And this is benzene trialdehyde, zinc amalgam HCl. This is the named reduction reaction. All aldehydes turned into methyl, so that A, B, and D are able to give the expected products in this manner. So that we can answer the question 4 as A, B, and D. Move on to question number 5. Question number 5 is given from analytical part. Again, we can say this is the what we can say volumetric analysis. The equivalent weight of which of the following is maximum? Equivalent weight, molecular weight, molarity, normality, molality, all these are the part of what? Titrimetric analysis or volumetric analysis or analytical part. Okay, practical chemistry related one. And in order to go for the simplification, they mentioned with their atomic weights. Sodium atomic weight is given as 23, manganese with 55, chromium is given as 52, potassium 19, oxygen 16, carbon with 12. So these are the atomic weights. Same question mentioned in Telugu as well. క్రింది వాటిలో దేనికి తుల్యాంక భారం గరిష్టం? తుల్యాంక భారం అంటే ఏంటిది? Equivalent weight. Okay, so this is the a specific question related to distinguish molecular weight and equivalent weight. ఇక్కడ ఇచ్చిన డేటా ఏంటిది? పరమాణు భారాలు, సోడియం, మ్యాంగనీస్, క్రోమియం, పొటాషియం, ఆక్సిజన్, కార్బన్ పరమాణు భారాలు ఇచ్చిండ్రు మనకి. వీటిని బేస్ చేసుకొని మనం తుల్యాంక భారాన్ని లెక్కగట్టాలి. అంటే ఏంటిది? ఈక్వివలెంట్ వెయిట్ టు బి ఐడెంటిఫైడ్. ఫర్ దట్ పర్పస్ we have the options like sodium oxalate dihydrate, potassium permanganate under acidic conditions, potassium permanganate under neutral water condition, potassium dichromate under acidic condition. Among all, what we can say, sodium oxalate dihydrate having higher equivalent weight. We have to go for its calculation. In order to calculate, we have to write it's a chemical formula. Sodium oxalate dihydrate. How can we write? Oxalic acid is known to each and everyone. Whenever 2 hydrogens replaced with 2 sodium, sodium salt of oxalic acid will be formed. It is the dibasic acid. 2 hydrogens are replaceable. This is important to remember. 2 hydrogens are replaceable. And it is accompanied with 2 moles of water. So this is the Na2C2O4 2H2O chemical structure is mentioned like this. Here, let's go for the molecular weight calculation. Molecular weight can be calculated by taking individual atoms. How many carbons you can notice? 2 carbons. 2 carbons accomplished with 12 atomic weight. So that 2 multiplied with 12, 24 atomic weight of carbons. How many oxygens you can notice? 4. 4 oxygens. So that 4 can be multiplied with atomic weight of oxygen, that is 16. 64 is the total atomic weight of oxygen. How many sodiums are there? 2 sodiums, and each sodium contributes 23. 2 sodiums 46. How many water we have? 2 moles of water, dihydrate. So each water gives 18 molecular weight. 2 multiplied with 18, so that 36 for water molecules. If you add all the numerals, so that 170 is the molecular weight of sodium oxalate dihydrate. This is the molecular weight. They're asking for equivalent weight. The calculation of equivalent weight, we have a different kind of representation for different materials. If you go with acid, how many H plus it is releasing, called its valency. If you go with the base, how many OH minus released is called its valency. If you go with salt, how much charge is there is its valency. If you go with oxidizing agent and reducing agent, how many electrons got transferred, that is its valency. Okay, based on the nature of the compound, valency can be calculated. Acids H plus, bases OH minus, salt charges, oxidation reduction electrons. This is the way you can go for the calculation of valency. So when you are going with the molecular weight by its valency called It's a equivalent weight. What is the formula for equivalent weight? Equivalent weight is equal to molecular weight by valency. Molecular weight is calculated as 170. What is the valency? It able to generate two negative charges or else two positive charges, so that its valency is 2. COO minus COO minus, or else Na plus Na plus. Two negative charges you can count, or else two positive charges you can count. The valency must be 2. So that 170 can be divided with 2. That will become 85. 85 is the equivalent weight of sodium oxalate dihydrate. Move on to second compound. Second compound is having KMnO4, potassium permanganate. Potassium permanganate in this manganese is having oxidation state +7. Oxidation state is of central manganese state taken as a +7. But under acidic conditions, manganese +7 will be converted into manganese +2. +7 if converted into +2, what difference you can notice? 5 electrons will be transferred. This is the kind of reaction where oxidation reduction carried. In case of oxidation reduction, what we have to observe? Electrons traveled, electrons shifted, electrons transferred, we have to notice. +7 to +2, the shifting of electrons are 5. So that 5 is the valency of this KMnO4. So that molecular weight of KMnO4 you can take, that is 158. Molecular weight of potassium permanganate is 158 and its valency is 5. Molecular weight by valency is called its equivalent weight. So that 158 by 5, that will be 31.6. What we calculated for oxalate, 85. For potassium permanganate, 31. Remember second. Move on to third. Potassium permanganate under neutral, that means under water conditions. If you go for water condition, there what you can notice here, +7 will be turned into +4. +7 will be converted into +4 oxidation state. +7 to +4, what difference you can notice? 7 to 4, in between difference is 3. So that you can put a 3 valency over there. Molecular weight remains the same, being it is the potassium permanganate, again it remains same 158, but valency value changed, it is 3, either basic or neutral. For both the conditions, valency will be 3 only. So if you take 158 by 3, the value will become 52.6. 52.6 for basic medium, 52.6 for neutral medium. But acidic medium, 31.6 only. The purely depends upon electrons traveled or valency in that medium. Acidic medium, basic medium, neutral medium, we have to identify. Okay. Neutral medium value is 52.6. Acidic medium value is 31.6. Okay. One more thing we have to calculate is for potassium dichromate. Potassium dichromate under acidic conditions. Whenever potassium dichromate taken into the consideration, chromium existing in +6 oxidation state around the central chromium. Upon reaction, it turned into +3. How many electrons transferred? 3 electrons difference. 6 to 3. +6 turned into +3, right? So that electron difference is 3 only. But 2 moles we are considering, so that 6 is the valency. If 6 is the valency, in order to calculate the equivalent weight, what is the formula? Molecular weight by its valency. Molecular weight of potassium dichromate is taken as 294. Potassium dichromate molecular weight is 294. Valency, electrons transferred are 6. So that 294 divided with 6, the value, equivalent weight value is 49. 49 for K2Cr2O7. KMnO4, 52.6. KMnO4 under acidic condition, 31.6. Sodium oxalate dihydrate, 85. Which is larger value? Obviously, 85 is the larger value. 85 is given for sodium oxalate dihydrate, so that highest equivalent weight will be accorded for sodium oxalate. Here, the point we have to understand for this question is, in order to answer such a question, this is a simple fundamental in the analytical chemistry, analysis part or practical chemistry we can say. In order to calculate this, first thing, how to calculate the molecular weight is most important. After that, How to convert molecular weight into equivalent weight is important. Molecular weight divided with the valency. But valency will not remain same for all the compounds. That depends upon nature. Acids, what is the valency? Base, what is the valency? Salt, what is the valency? Oxidant, reductant, what valency we can take. So everything we have to know, then only we can answer such a simple question. For question number 5, option number 1 will be the correct answer. Move on to question number 6, last question of the session. Identify the measured product B in the given sequence of reactions. Series of reactions are there. What is the final product B we have to identify? క్రింది చర్యాక్రమంలో ప్రధాన ఉత్పన్నం B ని గుర్తించండి. Starting material is propane treated with hydrogen in the presence of palladium carbon. What is the product A? So already it is mentioned with the hydrogen palladium carbon. If you are taking platinum, so that complete reduction is possible. But palladium carbon is a kind of reagent which is some extent mild, so that partial reduction it will operate. Partial reduction means here you have two pi bonds, but being it is the mild reagent, it will reduce only one pi bond still there, so that you will get a alkene, double bonded compound over there. The alkene will be treated with HBr. Whenever propene treated with HBr, the kind of reaction is addition. And here another logical condition is mentioned, that is benzoyl peroxide. Whenever benzoyl peroxide is added, it is the kind of reagent which will facilitate the reaction in a different manner. That is called anti-Markovnikov addition is possible. So that a anti-Markovnikov product you can get, that will be a B. In order to get this, let's see the detailed mechanism. There are the options. Anti-Markovnikov product is 1-bromopropane. This is the expected product. If the reaction proceeded with Markovnikov rule, that is 2-bromopropane. But anti-Markovnikov rule they mentioned. Where they mentioned peroxide, they mentioned no. Peroxide always shows the Karash effect. So that anti-Markovnikov product we will obtain, that is called 1-bromopropane. In order to achieve this 1-bromopropane, we have to go for a detailed mechanism. Let's see how can we go for A and B first. Sorry. Whenever propane is treated with hydrogen in the presence of palladium carbon, triple bond converted into double bond. Just now we said it is the kind of mild reagent, partial reduction, one bond only reduced. Later on, HBr will be added. We have two possibilities. Either bromo can be added on carbon 1 or carbon 2. But specifically, carbon 1 will be added with bromo, and the product is expected to be 1-bromopropane. Right? So here we have a double bond upon bromine will be added. Under this benzoyl peroxide, the mechanism purely radical, free radical mechanism, so that fission is homolytic, bond cleaved equally, and bromo will be added at this terminal carbon. Endukante here the carbon whichever present in between, that is the secondary. In comparison to primary carbon, this will be more stable. That's the reason why. So here secondary 2-degree carbon radical will be generated. Later on, H radical will be added, so that CH3, CH2, CH2Br will be generated. So this is the reason why the stability of intermediate is the driving force in this reaction, right? The mechanism proceeded with the free radical, and benzoyl peroxide is a homolytic fission facilitating initiator, so that entire mechanism is homolytic fission. Free radicals will be generated. 1-bromo is called anti-Markovnikov product. Let me give the definition for anti-Markovnikov rule. Negative part of the reagent means bromine. Negative part of the reagent will be added to the carbon having more number of hydrogens. Here the carbon is having 1 hydrogen. Here the carbon is having 2 hydrogens. Obviously, bromo will move to more hydrogens containing carbon. This is called anti-Markovnikov rule, right? So that we will get this 1-bromopropane as the product. That is given in the option number 2. For question number 6, option number 2 is the correct answer. By this, we entirely completed the session where we covered with the various sections of the chemistry, which will definitely increase your interest towards the learning of chemistry. A best learner will always search for the new things, so that the kind of session what we are adopting will be taken from various authorized websites. Authorized domains can be taken wherever already existed questions, already completed questions, completed examinations are taken into the consideration in order to give more informative content over there. That's the reason why I'm sincerely requesting to each and everyone to like the channel and comment, which is important for your serious preparation, and share with aspirants who are very curious about their cracking their goal, and subscribe the channel to achieve more such updates in the near future. Thank you very much for your patient listening. Thank you, one and all.